is now recording. All right, so there's a bit of a change to the Year 11 course outline compared to the 2023 version. I've updated it here for you to see. Let's have a look at the planner. What's changed is the set of questions and what we're focusing on for the Year 11. In the past, I used to teach the Year 11s to do the entirety of sketching a circular function, and there's one technique for it that I normally do. And on your sheets, that's what it guides you to do. What we're going to be doing instead this year is, in the interest of time, but also maybe complexity or simplicity for you, when we're doing graphs, so 14F, 14H, and 14I, essentially is just sketching sine and cosine graphs. Okay? But there are three levels of sketching. There's one where you sketch with no translation, so it means you don't move it up or down. There is, you move up, so vertical translation. And then you've got the third one, which is essentially horizontal, but that can combine with vertical. So in the past, to do a full sketch, you do both horizontal, vertical translation, as well as a dilation. And that is the most complex version that you can get. And in my example there, on the very last page, I've given you a set of questions from the Year 12 textbook, that essentially that's what they have to practice to do. The problem to it is it can take, for the first time students doing them, it can take 25 to 30 minutes to do one graph. If you were to do it properly. For the first time, because you're sort of like, there's so many things to think about. On average, I found that students take about 25 to 30 minutes. So, hence, the worksheet I usually do, it takes about 2 sessions, and you can cut it down to 10 to 15 if you're pretty well versed in what I'm teaching you, and then obviously you could do it in less than 10 minutes if you're better. Okay, but so how do we cut that time? We essentially think, just to get students a bit more familiar, we do vertical, and vertical is much quicker to do. Okay, so you can have a bit of dilation, but if you're just doing vertical translations and no horizontal, it does make it easier to do. Okay, so that means when you're looking at your questions to do, only do the vertical ones, and we've chosen the vertical ones for you. For 14I, question A, B, C, D, and 2 ACD is only required at Year 11. Next year, when you come in, then we'll likely teach you the horizontal together. Okay, so it is a pain to sketch, but that's the update for you. And with that, that means it makes it easier to also get through the sketching. So, let's have a look. Today's lesson, Unit 02. So previously, I would have taught you how to do these kind of problems, skipping to this page, that one. So previously, I would have taught you how to do it when you have vertical translation. I would have taught you how to do it when you have a dilation as well. So that's from the y-axis, and what that does is it's a horizontal compression, so dilation from y-axis. Compression's bad because that means instead of your graph normally looking like this, and that means you only get how many x-intercepts? 1, 2, 3. If we compress the graph within the same window, within that same box there, if I make it thinner, then you can get, multiple intercepts. You can get now 1, 2, 3, 4, 5, 6, 7, 8. Usually 8. 6 to 8 is what they would usually get you to do, and so that's a lot more problems. So with just that number 2 or number 3 or number 4, that can change your problems drastically. So we still will be doing that dilation, except it saves you a lot of work if you don't have horizontal. So in the past, that's what we would do. Today's lesson, we are going to cut away this bit. So I'll do graphs that doesn't have that extra horizontal translation, but I will teach you how to read the amplitude, the period, and how to sketch the graph when there is a vertical translation. So whatever's highlighted in yellow. Okay? So when you're doing the questions, those are the things I want you to look for. So if I zoom out, when you're doing 14I, which saves you from doing FHI, you can just jump to I and practice. But if that's too much, then each one is an increment. Okay, don't do these questions. These ones have horizontal. Anything that has a horizontal translation, don't do. Okay, it changes your problems a bit more, especially if you add on dilations in front of. So notice they all have that dilation. That dilation will make your life a bit harder and more calculations to do. So we're trying to keep it simple. Just do vertical translations only, and the dilations will make it trickier. But if you just stick to translations, it should be easier to do. Okay, so I would recommend you to start off, if you're just wanting an entry level, you've got a lot of exercise to catch up. 14F is entry, just something like that one there. And then when you're ready and you're caught up, then I'd say start at 14I and do the set questions we've set. So it was A, B, C, D. So notice, has vertical translation, no horizontal, vertical translation, vertical translation, vertical translation, but don't do that one. Okay, so anything that has a horizontal translation, don't do. Okay. All right, team. So let's get on to starting off. How do we sketch, and what are some things that we can start off with? On the very first page of your notes, here we go. We're going to look at the shapes of your graphs. Usually I also explain why the shapes come about, so I'll give you a bit of a visual idea. If you get it, great. If you don't, memorize the graphs. So here, this is a typical sine graph. Okay, so y equals a times sine of n times x. This is a typical sine graph. You've got this shape that kind of oscillates up. It goes up to a maximum of 1, comes back down, and then comes back to -1, and comes back to 2 pi. This is your typical sine, one revolution of a sine graph. What you probably want to understand is that this is kind of like your quadratics. You know how when we give you y equals x squared, you tell me it looks like this? When I give you y equals 1 on x, you tell me it looks like this? When I give you y equals root of x, you tell me it looks like this, right? Well then, when I give you y equals to sine of x, I want you to remember it as that, okay, in general. That's what it looks like, okay? And then the key point to make a difference between cosine and sine, so this is sine, and this is now cosine. Cosine, notice it starts at the maximum. Then it comes down to the middle, then it goes to the bottom. Versus, sine always starts at the middle, goes to the top, comes back to the middle, then goes to the bottom. See the difference between the two? So one starts at the midline, one starts at the max line. That's the only difference between the two. Okay? So the shape, when you draw them, if you look at them on Desmos, it actually looks the same. So if I go to Desmos now and show you, let's go to Desmos. This is what a sine graph looks like. Sine of x. See how it's a bit of a wavy line and it goes infinitely? Well, when I type cos of x, it also is a wavy line, goes infinitely. So it almost feels the same. The difference is, though, where the starting point is. And we like to think on a Cartesian plane, just at the x value, one starts at the center, one starts at the very top. So the blue line is your cosine, and your red line is your sine. Obviously, later on, as you understand it, they're actually complementary angles. So they differ by 90 degrees. Okay, so therefore, if I just move the graph, for example, minus pi on 2, you can see it becomes the exact same graph because there are only a difference of 90 degrees. But that's for another session to find out. So today's lesson, what are you going to fill in? I want you to have a visual idea. So if I asked you, what does a cosine graph look like? I want you to have these two in mind. So you can write it as part of your notes or just remember from the notes I've given to you. This is sine and this is cosine. Okay, so cosine starts at the top and sine starts at the center. That's at least the beginning. Now, if you kind of can memorize the graph. That's the bare minimum. The understanding is, why does a sine graph start at the center and why does a cosine start at the maximum? Well, it comes back to the unit circle. Let's look at the sine. What does sine represent again? The x or the y coordinates? Which one? The y. So let's just focus on the y. I don't want you to think about anything else. So think about the unit circle. Imagine I had a rod, so like this, I start at 0. Right now, what's my y value to start off with, just at the very beginning? What's my y value? 0. This is one of the reasons why sine starts at 0, which is the center. So the y values start at 0, but as soon as I rotate 90 degrees, so each quadrant, let's have a look. I rotate 90 degrees, so I go like this, 90 degrees. I will end up here. So going all the way here, that's the distance. What's my y value now? 1. Yeah, so y value at that point, that's a maximum y value of 1, which explains, can you see in the graph, that's what's happening. You started off at 0. This is 90 degrees. So at 90 degrees, you did one rotation, and we made maximum height of 1. So this is essentially representing quadrant 1. You're just increasing. Yeah. So that rotation that I did, rotated to 90 degrees, it was increasing in height to 1. If you look at the unit circle again, what happens after you go from 90 degrees to 180 degrees? You see that rotation, my y values are actually dropping. It's getting smaller and smaller and smaller and smaller until it reaches 0. That is why, as you can see, by the time I rotate to 180 degrees now, a total of 180 degrees, the y values is back at 0. And that's what you're seeing. This graph is essentially telling you quadrant 1, quadrant 2, then quadrant 3 for your y values. In quadrant 3, the y values are negative. And then this next bit is quadrant 4. That's one revolution. And that's the idea. Okay, so if you look at cosine and sine graphs, that's what you have. If that made sense to you, fantastic. If it doesn't, this is all you need to know for exercise 14F to begin with. Two key terms. Amplitude. Out of curiosity, have you learnt what the amplitude is from your previous years? Hands up if you know. Oh, only 3. Okay, actually I thought it was taught in year 10. Have you guys learnt sine graphs, cosine graphs in year 10? Oh. All right, amplitude. Well, this is worthwhile writing then. Amplitude is the measure between the middle line, so the midline to the maximum, and the minimum has to be the same. So amplitude, in this case, because it's symmetrical, amplitude determines that height from the midline. Okay, so how do you find the amplitude? You usually get the maximum plus the minimum and then divided by 2 because you're finding the average. Okay, so if you didn't know, write this in. Amplitude is equal to the max plus the min divided by 2. You can also find the amplitude by the letter A. The letter A. Whatever you're dilating, so remember A represents a dilation. It means a vertical stretch. So if you stretch that graph, you put a 3 in front of it, it changes every value, everything gets stretched by 3. So you can see here on a graph, if I went back to Desmos, let's see what happens. Y equals, let's zoom in. Here's my sine graph. What's my amplitude at the moment? What's the amplitude? What's the height from the midline to the maximum, or the midline to the minimum? What's the height? What's it equal to? Anthony? 1. Now the answer here is clearly distance of 1. So we say amplitude is 1, but notice A is currently also 1. But as soon as I change that, I made it a 3. Notice that the shape gets stretched vertically. The intercepts are still the same, but notice the height now is at 3 pi on 2. Oh, so not 3 pi on 2, it was... Did I do something wrong there? Sine of x. Oh, sorry. It's pi on 2. Pi over 2, 3. There we go. And there's my point, my maximum. So 90 degrees, after I rotate 90 degrees, it is now at a height of 3. So that's my amplitude. So what you can see is some students would just generally memorize in 14F that the number in front of sine or cosine determines amplitude. So let's do a quick practice. What is the amplitude? I'm just going to have a look at 14F here. What's the amplitude of question 1B? Can I please have Artie? What's the amplitude? 3. It's the number that's multiplying to the function. So that's my amplitude. Let's do another one. What's the amplitude of 1C? Can I please have Lillian? Yeah, it's 1 over 2. It's whatever you're multiplying to the function. That will determine where the amplitude is going to be. Pretty easy. So the first step of exercise 14 is to look at graphs. Amplitude is half there. Amplitude is 4 here. Amplitude is, now be careful with this one. What's the amplitude for F? Not minus half. It's actually just still 0.5, because remember, what was the definition of amplitude again? Definition was the distance from midline to max line. The negative only just flips the graph, but it doesn't matter if you flip the graph because the distance from the midline to the top or the distance from the midline to the bottom is still going to be the same. You just flip the graph. So even if I swap this one around, say put a -3 there, yeah, it flipped around, but if I asked you what's the amplitude, it's still 3. From the midline to the top line and the midline to the bottom line, it is still 3. So be careful. Most students will say -half. Okay, so it doesn't have to be. Amplitude is actually just the absolute value, meaning it's always going to be positive. So here's your first one. Amplitude tells you, and just can you write on a corner here, always positive. Doesn't matter about the sign. Okay, write always positive. So you can either find the average of the maximum minimum, or you can just read from the function. Whatever you multiply to the function, that should give you the amplitude. Next one, period. Period determines how long does it take to do one revolution. Okay, so in this case, we can see it started from 0 and you landed back at 0 again after 2 pi. And then the cycle begins again. Okay, so then the cycle then continues, it goes up, comes back down, comes back up. So that oscillation, each cycle, is called a period. Now, how do you work out the period? Well, clearly in this example, it is 2 pi, because it takes one revolution, it takes 2 pi distance to make one revolution. So starting from 0, I had to go 2 pi distance to make one revolution. And then you do it again, and then you do it again. So each one draws a cycle. So your period is normally 2 pi. But what changes that? It's the letter n. Remember, n is the horizontal stretches. It's a dilation. So if I squeeze it together, if I compress it, you get more shapes in between. So for example, here's my sine of x graph. But watch what happens when I do y equals 3 sine, and I just put a 2 in front of the x. See that? You're compressing everything by half. So instead of in between 0 to 2 pi, which used to be one cycle, I now have 2. That's 1, 2. In the same length. So because of that, your period now changes depending on n. Now, if you remember, this n value is a dilation of factor what again? Back to chapter 7. Anyone remember? When you're dealing with the x, it is from y, but the factor. What happens to the factor? You've got to be careful with the factor. What is it again? Is it factor... Anyone remember? So for example, if I gave you root of 2x and I said, tell me the transformation. You'd say dilation of factor everyone's forgot. Okay. Anything to do with the x, remember it becomes a reciprocal. It actually is 1 over 2. That's what most students tend to forget. Whereas if it's 2 at the front, you say dilation of factor 2 from the x-axis because you're affecting the y. But when you're affecting the x-axis, then it's the reciprocal. And we showed that in chapter 7 with the algebra, why it actually becomes a reciprocal. Yeah. There will be 1/2 from y. That will be for that particular transformation there. And then if there was a number outside the function, that will be dilation, I don't know, let's say put a 3 there, dilation factor 3. So what's different about this one? This is from the x. Okay, so from x, but the number actually stays the same. When you're dealing with the x's, everything gets reversed. Kind of like when you move left and right. Have you noticed that when we say x minus 1 squared, and I ask you, is this quadratic moving left or right? Most of you would say, this moves. Right, yeah, but it's a minus 1. Interestingly, it's minus 1. Whereas when we go up or down, it goes with the sign. So if it's plus, it goes up, and it's minus, it goes down. This might mean that you guys might need a bit of revision on chapter 7, because that is important for next year. The things I'm asking you at the moment becomes prerequisite knowledge as you walk in to be able to say dilation, left, right, up, down. Those are the kind of things that you want to feel confident in. But if I'm confusing you too much with chapter 7 prereq knowledge, then you can memorize this rule. It's 2 pi on n. I wanted to show you why it was on n rather than just memorize the rule. It's a dilation of factor 1 on n because you're compressing it. That n makes it compressed, but you have to know why it's 1 on n to begin with. And so if you take 2 pi and you times by 1 on n, that's how you get 2 pi on n. But if all of that was too confusing, then this is what I want you to memorize then. I don't think maths should be memorized, but to get you going, maybe that's the way to go to start off with. So 14F, amplitude and period. So amplitude is the number in front of sine or cosine, and period you can work out by doing 2 pi divided by n. Okay? So in this case, when I gave you y equals to sine of x, n is 1 and a is 1. So amplitude is 1 and then period is then 2 pi. Okay, so you can see period becomes 2 pi divided by 1 and you get 2 pi. That's 14F. So what do you have to take out of 14F? Sine graph, cosine graph, amplitude, period. 4 things. Okay, 4 things to sketch a sine and a cosine graph. We're going to do an example because I feel like this might be throwing you off with a bit of theory there. So we're going to do some example just to consolidate your understanding. Let's do an example. Flip over to, which one can I get you to practice? Let's do 14F question 4. Let's pick one. I'm going to pick one with a negative and then one with a positive, okay? Let's do B and I'll do I, okay? Here we go. Question 4B. In order to sketch y equals 2 cos of 3 theta, or you can write x if you want to. Notice they tell you just to sketch one cycle. So they don't actually care what the domain is. We're going to sketch one cycle. So let's begin. Here we go. Let's do this one example. Draw an axis. Y, x. Let's test your understanding so far. There were 4 things I asked you to do. 1, to remember the shape of the graph. 2, amplitude. 3, period. And then 4, whether you know what changes in the dilation. That's it. Okay, so here we go. Amplitude. What is the amplitude for this particular question? 4B, can I please have... Let's go, who have I checked for a while? Lucky. 2, amplitude's 2. So what does that mean? that means that from the center to the maximum, center to the minimum, it is a height of 2. So that means you get 2 or negative 2. That's your barrier. That's your range. That's as far as it can go because we know the amplitude is 2. So it goes from center up, center down. Next one. Period. Period was given by the rule 2 pi on n. What is my n in this case? Can I please have Anthony? What's n? 3. So that means my period must then equal to 2 pi over 3. What does that mean? That means when you draw one cycle of this graph, it should take 2 pi on 3 with distance. So, next part. What does a cosine graph look like? Does it look like this or does it look like this? Number 1 or number 2? So this is 1, 2. Which one is that, Milena? 2. So if I were to draw this graph, it starts at the top if x equals 0. But in this case, I'm not talking about domains yet. So starting off at 0, then it's top to the middle, down to the bottom, back to the middle, and back to the top. Here's my cosine graph. So how long did it take to draw that? We said a period of 2 pi and 3. So here, it should be 2 pi on 3. That's how long it takes to draw one full circle. Halfway point, halfway, so it takes you to go all the way down before you go all the way back up, is half of 2 pi and 3. And this is where you have to do a bit of fractions. What's half of 2 pi and 3? Dumafi, what's half of 2 pi and 3? Two pi and 3 times by half. What does that give you? 2 pi and 6 can be reduced. So timesing fractions, 2 pi times 1, 2 pi. 3 times 2, 6. But 2 pi on 6 gives you pi over 3. There we go. This is what I mean. Why is this chapter really challenging for a lot of students? It's the fractions. It literally is the fractions and the surds and all that gets the students. All I asked was half of a number. If I said half of 10, all of you would have answered. But all I changed was 2 pi and 3. In fact, if I didn't even say pi, if I said, what's half of 2/3? Then there's a bit of processing. Yeah, it's because the fractions is scary for a lot of students. And often it's because in high school, or more like primary school, it wasn't well trained and then not practiced enough. By the time we get to year 7 and 8, it's usually skipped as well. Anyways, that is your graph. So you got maximum height, minimum height, you've got your width, that's your period, and I've just labeled the middle line so that you know pi and 3 will give you the minimum, 0 will give you the maximum, and then at 2 pi and 3 it gives you the maximum again. So that gives you a nice graph there. Let's try another one. I'm doing sine this time, but I'm going to do a negative version. So let's do I. Here we go. Y equals negative 2 sine of theta divided by 3. Be careful with that one. So let's start again. Amplitude. What is the amplitude in this case? Let's go with Zoe. What's the amplitude? 2. Good. It's not negative 2. It is 2. The negative just tells me it flips the graph. Next one. Period. What's the period equal to? Can I please have Artie? Be careful. So we've got 2 pi divided by n, and what's my n in this case? 1 over 3. So it's not 3. Okay, 3 was in front of the theta. Right now, this is the same thing as saying 1 over 3 times theta. So n equals 1 over 3. Now, this is where the fractions come in. Let's see how many people can do this simple fraction. What's 2 pi divided by a third? Or just to make your life easier, what's 2 divided by a third? What does that give you? How many thirds fit in 2? 6. For those who weren't sure on how to do this, 2 divided by 1/3, that's what I was asking. So when you say 2 over 1/3, you're saying what's 2 divided by a third? 2 times the reciprocal. If you like, this is what I heard from my year 8s. They learned the KFC method. Keep the first fraction. Flip the second fraction So flip it. Change the sign to a times. But that's what my year 8s are. Apparently they learned that in primary school. KFC method. So that might be useful for you. KFC, so it becomes 3/1. That's how we know it's 6. So period. 6 pi. Okay? But you never know. Maybe KFC could be useful for you there. Let's sketch the graph. All right, sine graph. We showed you before, sine does not look like cosine, so it starts at the center. We already heard the amplitude's 2, so you got a maximum of 2, minimum of -2. The graph has a period of 6 pi. We know a sine graph normally looks like this, but what do you have to be careful? Why is this wrong already? Why is it wrong if I draw it like this? Why is it wrong? I mean, that is a sine graph. What's the problem? It's flipped. Don't forget that negative. Negative was a reflection on the x-axis, so it flips vertically. So the graph should now go this way. Like that. So you still have a 2, amplitude of 2, both bottom and top, but it's flipped. How long does it take to draw one cycle? Well, we found the period. It was 6 pi. Now this one, most of you probably will answer quicker now. What's half of 6 pi? Elena? 3 pi. How easy is that? Does that feel much easier? That, right there, if you're practicing that, that is exercise 14F. 14F is an intro into getting used to labeling key features. So you've got amplitude, you've got period, okay, and you've got the shape of the graph. Okay? All right. I'm going to give you... Yeah, maybe I'll give you 7 minutes just to bring us to 9:50. 7 minutes. Can you pick a few questions from 14F? Maybe just sketch 2 types. 2 types. You can do question 2 as one of them. Or you can do don't do question 3 or 4 because that has a horizontal translation. I just realized this has a horizontal. So 2, 3, 4 you can't do. Do 1 A, B, C, D or... Well, that's it. I already did 2. Maybe you just got to pick 1 then. Oh, this is G. Oh, sorry, this is H. Where is one from 14F? 14F. Ah, here we go. Let's try 2. 2A is a good start. Let's pick another one. I did 4 before, so you guys can do 4F if you want to. 6 minutes, sketch 2 graphs for me and show it to me. I'm going to walk around just to see that you can sketch a graph. Now, for those who want a bit of a challenge, you can do something like this, question 6. Why is question 6 a bit harder? Because you have to start with a domain. So they're saying from -2 pi to 2 pi. Rather than just sketching it, now you have to think about the x-axis, -2 pi to 2 pi. Have a go with this one. I'm going to pause the video.